Hello, this is Mr. White, and this video is on basic differentiation rules. We'll do two exercises in this video, and in the first one we'll find the slope of a graph given the equation and a point. And in the second exercise we'll find the derivative of this somewhat ugly looking function, but we'll find it's not as bad as it may look at first sight. So back to the first one. Find the slope of the graph of the function at the indicated point. Use the derivative feature of a graphing utility or a calculator to confirm your results. I'm going to add on to that. This is what was presented in our textbook or something similar to what was presented in our textbook, but I'd like to add on this additional task, find the tangent line equation, because I really want to compare and contrast and make sure that you understand the difference between finding the derivative versus finding the tangent line equation. Those are two different things. Also, I want to point out that in our textbook, we were given both the x and the y value of the point. I'm only going to give you the x value, and if we feel we need the y value, we can find it out using this equation. So sometimes all you're given is the x value, and you need to know what to do with it. Okay, so we know that the derivative is what's going to give us the slope of the graph at any x value. And so let's go ahead and take the derivative of this function. If this function were simply 6 times just x squared, then we could use the power and constant multiple rules, no problem. But since we have a function within a function here, since it's a function of x, 3 minus 2x, and that's what's being squared, we really have no choice at this point but to FOIL that out. Now later on we'll learn something called the chain rule, which will give us other options, but for right now, just FOIL this out. So 6 times 3 minus 2x times another 3 minus 2x. That's going to give us 6 times 9 minus 6x minus another 6x plus 4x squared. And when we write this out, I'm going to, a lot of students, and I actually prefer putting this in standard form. So let's do the 6 times the 4x squared first. The standard form is where you have the exponents decreasing. So here's an exponent of 2 followed by an exponent of 1, 72x to the 1 power, followed by our constant, plus 54, right? Now, reminder, we haven't done any calculus yet. This was just algebra. And also, again, point out that if this were something like to the 20th power, we'd go, wow, do I really have to FOIL that out 20 times? Well, no. Again, we'll learn something else called the chain rule later on, which will make that a lot easier. But let's go ahead and do the calculus now. So that was just rewriting the function, FOILing out the function. And now we'll do our derivative of x squared is going to be 2x times 24. That's the constant multiple rule. Will give us 48x. And then minus 72 times x. If I took the derivative of x, if you think of the line y equals x and ask yourself what's its slope? Well, its slope is just 1, right? Y equals 1x. So if I multiply by 72, I get minus 72 times 1. And if we were to just graph y equals 54, that would be a horizontal line, right? And what's the slope of that? It's 0. So that's why the derivative of a constant here is 0. Okay, so I've done something a little bit incorrect here, and I'm wondering if you spot it. There's something that is bothering me about what I have written on the page here so far, and it is that, yes, I had a y here, and a y here, and a y here, so it's okay to leave it blank. That's customary. But in that last line, I no longer have y. I have y prime. So make sure that you note that. As soon as you take the derivative, explicitly say so. Okay? So this is our derivative, and again, this is not the tangent line equation itself. This is the function that will give us the slope of any tangent line for any x value, but it'll just give us the slope. Okay, so at an x value of 2, and that's all I need. Again, I don't even need the y value, I just need that x value of 2. If I take y prime of 2, if I plug the 2 in, I'm not multiplying y prime times 2, this is my function notation, y prime of 2, I'll get 48 times 2 minus 72. That's going to be 96 minus 72. That's going to be 24. And initially, that's all we're asked to do is to find the slope at the x value of 2. So I've accomplished this part of the question. And we are to use the derivative feature of a graphing utility to confirm our results. But I'm going to say again, let's do this extra little bit here just so I can make sure we're absolutely clear on the difference between finding the derivative and the tangent line. When you're asked to find the actual tangent line, you'll find the derivative like we just did, but we'll then say, we'll use that point slope form, y minus y1 equals m times x minus x1. And again, this 24 that we just calculated over here, that is the m. That's the slope of the tangent line. So that's the 24. And even though it says x equals 2 here, I really need to recognize that that's what I'll plug in for x1. So I'll x minus 2 here. And as far as what do I plug in for y1, that's what I was commenting earlier. If you're just given the x value, plug it into your original function. And if I have 3 minus 2 times 2, and then I square it and I multiply by 6, I'm going to get 6. And it turns out, by the way, that's what was originally under here. I had both the x and the y given, but I wanted to pretend that we're just given the x value. So this is our tangent line equation, and I've said it before, you can put a box around it there, although if you're going to check it via calculator, we need to put it in slope-intercept form. And that would be y equals 24x. See, that's going to be minus 48 plus 6. That's going to be minus 42. So again, for checking purposes, we'll put it in this form. Okay, and again, I emphasize one more time, this derivative, which we got over here, tells us the slope of tangent lines. This is an actual tangent line itself at a given x value. So let's check all of that. Let's bring up the calculator. And I've typed in just the original equation, the original f of x, so to speak. And I've got some decent window settings here that I've pre-entered into the calculator. And it gives me a graph that looks like this. It's a parabola, there's no surprise there. And let's check what the slope is at x equals 2. So I'll go to second calc, enter number 6 on the keypad, and I'll type in 2 and hit enter, and I see, yes, it is a slope of 24, and that is what we anticipated it would be down here. But let's go ahead and check the tangent line equation that we came up with as well, down here. So I'll remind you where that is. That's the second, and then I go to the draw menu, which is right above the program button, and I'll press number 5 on my keypad, and then I'll type in the x value of 2 again and hit enter. And I see that the actual tangent line equation that the calculator gives matches the one that I got earlier. Okay? Let's go on to example or exercise number 2. Find the derivative of this function. And again, later on when we learn the quotient rule and other more advanced rules, students will be tempted to jump right into that quotient rule. But right now, it's almost an advantage that you don't have a whole lot of skills because it really forces you to acknowledge that just a little algebraic simplification can go a long way. Remind yourselves that this could be split into 4 different fractions. You could have 9t to the 4th over t cubed minus 8t cubed over t cubed plus 7t over t cubed minus 4th root of t over t cubed. So whether you want to write it out like that or just envision that in your head doesn't really matter to me, but I'm going to just envision it in our head. I'm going to think 9t to the 4th divided by t cubed, that's going to give me just 9t, right? Minus 8t cubed over t cubed, that's going to give me minus 8. Plus 7t over t cubed, that's going to give me plus 7 over t squared. But anticipating that I'm going to derive it in the next step, it's much more convenient to write 7t to the negative 2 for deriving purposes. And finally, on that last part, remind yourself that this last little bit, that's really t to the 1/4 over t to the 3rd, which I could think of as 12/4. So t to the 1/4 divided by t to the 12/4, that's going to be minus t to the negative 11/4. I subtract those exponents. All right, so I haven't done any calculus yet. That was just algebra. Now when I do the calculus step, as I emphasized in the previous example, or previous exercise, now I'll denote that I'm taking the derivative. This is no longer p of t, now it's p prime of t. And the derivative of 9t is going to be just 9. The derivative of a constant is going to be 0. If I feel like it, I'll put plus 0 for emphasis. If I apply my power and constant rules, constant multiple rules, I'll get minus 14t to the negative third. And I'm going through those a little quickly. I hope you're at a point where you see where I'm getting these from. And of course, if not, absolutely come on by and let's figure it out. Now this is minus, again, I bring that negative 11/4 in front. That's going to become a positive 11/4. Just for emphasis, let me go ahead and write minus negative 11/4 t. And if I take this exponent and if I subtract 1 or if I subtract 4/4, I'll get negative 15/4. All right, not too bad. I should just clean this up in whatever way I can. Since we're all done with the calculus, I'll go ahead and just say that's 9. I'll ignore the plus 0. Again, a lot of books and teachers would insist that you don't have a negative exponent in your final answer. I don't care a whole lot, but I'll go ahead and go along with that convention here. And then finally, plus 11/4, and then a t to the positive 15/4 in the denominator. So let's check on the calculator. There I've got the original function, p of t, entered in as y1. Now notice instead of p of t, I've got y1 as a function of x, but we can make that connection there. And then for y2, that's my p prime. That's my derivative function. Here are my window settings that I've pre-entered that seem to work pretty well for this problem. And I go to graph. So again, in bold is the original function, and not bolded is its derivative. I'll go to second calc, option number 6, press 6 on the keypad, and let's just pick a convenient number like 1, and hit enter, and I see that the slope of the tangent line there is negative 2.25. If I jump using the arrow keys to the derivative function, and I see up on the top of the screen, I can tell it's the derivative function, I see that the y value is negative 2.25. Let's check one more point, second calc number 6. Let's check at x equals 2, and I see I'm getting 7.45, etc. And if I jump to the derivative function, I get 7.45 and change. So we'll say that that looks pretty reassuring that we have got the correct answer here.